We're going to talk about the perfect cubed root numbers that we're going to use whenever we do a t-chart. Oops. Yeah. So perfect cubed root numbers, -8, -1, 0, 1, 8. Those are our perfect cubed roots. The outputs should be perfect integers. That's why I like these numbers. Like using these numbers for we call this the parent function, by the way. Whenever you can describe something in one box, whenever we talked about words, how do you describe a function using words? Take the third root of it. All right, so this is called the parent function. Now we got to figure out, okay, how does this 3 affect it? Does it affect the inputs? Does it affect the this side of the t-chart? Does it affect the outputs? We're going to take all of these outputs and multiply them by 3. I'm going to keep all the inputs just the same. I'm going to use -8, -1, 0, 1, 8, but I'm going to multiply all these outputs by 3. Now, when I start to graph, I don't have -8 or room for -6. So what I'm going to do is I'm going to change the increments to go up by 2s. The way I'm going to show it in my graph is I'm going to put a 2 in each spot for the positive x-axis and the positive y-axis. If you would like to increase, or if you would just like to show all the increments, that's totally fine. But it is actually sufficient enough to put 1 increment on your x-axis, and it is assumed that all tick marks or all increments increase by that amount. Now, note, you can't change this to a 2 and then go to 3. And then go -1. Like, you can't just switch up the increments halfway through. It's just assumed it's constant. And we get, I guess, a swimmer. My swimmer arms. I don't know why I like to call it the running man. I don't know why. But I do. Next problem, 3 times the cubed root of x minus 2. If you want to do your homework using these transformations, figure out the t-chart of that, and then move on from there. So if you have a leading coefficient, try to figure out, okay, leading coefficient times our main function, and then figure out, okay, from here, what would be affected. We're going to use that previous table. So after using the previous table, we got to figure out how does this -2 affect it. So I'm going to affect the inputs because it's inside the function. How do I affect the inputs? I've got to figure out, let's see, in my chart, in my notes, I'm looking for this sort of thing. I'm inside the function subtracting a number. What does it say to do? After looking at that table, the inputs are going to move right to. So the outputs don't change. They stay -6, -3, 0, 3, 6. The outputs stay. It is strictly the inputs that will move right to. You've got to figure out, moving right, is that a positive or negative direction? It's a positive direction, so I'm going to add all the inputs with 2. So -8 plus 2 is -6. -1 plus 2. Again, I've got some big numbers, so I'm going to change my increments to be 2. Let's recap what we did. We already produced the t-chart for 3 times the cubed root of x for the previous problem. So then we tried to figure out, okay, is this -2 inside the function or outside the function? Since it was inside, it affects the inputs. But going the opposite way of what we think. Instead of, well, we would think that this would move it left to, but it's opposite when it's affecting the inputs. H, because that's the position of that H has to change the sign. All right, let's move on to the next one. Because we've already calculated the table for 3 times the cubed root of x, I'm going to copy down that table. After you copy down the t-chart, now you've got to figure out how is this affecting our function. Is it affecting the inside or the outside? So because this is outside, I'm only going to be affecting the outputs. but I've got to figure out how is it affecting the outputs. In my chart, it's almost like I'm looking at a function, but then it's adding a number outside. So the outputs are going to go up 2. Therefore, I need to figure out, okay, up 2. I should only be adding 2 to the outputs. Inputs stay, outputs will change. Yeah, I think, again, I'm going to have to change my scale to be 2s, going up by 2s. So to recap, it was what was affecting our original, well, our function that we already have a table for. We're moving everything up to. Yeah, my bad. Everything moves up to. So we're going to start practicing square roots. We're going to test our knowledge on whether or not we can do this using transformations. So ladies and gents, let's go through the typical t-chart for a square root of x. This is a recap from yesterday. Perfect square roots. By the way, can't do any negatives. So 0, 1, 4. We could do 9. What's nice about a square root function is I kind of only need 3 points to get my arm. So the outputs, the typical outputs are 3, 1, 2. Or sorry, 0, 1, 2. We've got to figure out if that 4 is affecting the inputs or the outputs. So it's affecting the outputs because it's outside the function. So the outputs will multiply by 4. Inputs stay. And you graph. So ladies and gents, notice how this has an end point. Some people are drawing arrows down. But that arrow down is strictly the axis. It is an end point. There is no arrow connected to that end point except this one. That is the only arrow part of this function. Now, I want to talk about the domain and the range. Domain is affected by your inputs. Range is affected by your outputs. What kind of inputs did you have? What kind of inputs did you have? So, all the inputs had to be greater than or equal to 0. All the range. Let's talk about the range. What happened with the outputs? What kind of numbers did we output? All positive numbers and 0. 0 is a neutral number, so we do have to include that. Here is the exciting part of this. Domain is the inputs, range is the outputs. So if there is something that affects this, if I shift up or shift down, or shift left or shift right, that means either the inputs or the outputs gets shifted the same way. Looking at this next problem. So we already did the 4 root x, plugging it, no, not -8. We plugged in 0, 1, 4, and we got 0, 4, 8. So we've got to determine this new t-chart involving our old function with x plus 3. Oopsies. That 4 is not the index. That 4 is a coefficient. We got to determine, are we being affected by the inputs or the outputs? So the inputs are being affected. The inputs are being affected. And whenever we look at the inputs being affected, inputs have an opposite way of thinking. We're not moving right 3. We're actually going to move left 3. And you've got to figure out, if I move left, is that a positive or negative direction? It's a negative direction. So I'm going to take all of those inputs and subtract 3. Outputs stay. Inputs are now going to be subtract 3. Here's the exciting piece, all right? Or at least this is where you may feel a little liberated as you get to know this stuff. We just talked about how this affects the inputs, which out of domain or range affects the inputs. So now you got to figure out, is it domain or range that affects the inputs? It's domain. Domain affects the x's. So domain then, if the inputs are affected, domain is affected. So if all of these points moved left 3, that means the domain is going to move left 3. So we're going to be looking at a domain where x is going to be greater than or equal to negative 3. Which you see that that point is at negative 3. Moving on over. Because nothing was affecting the outputs, the range stays the same. So next problem, we have y equals 4 times the square root of x minus 5. We're going to go back to number 11, copy down that t-chart that we had, and then figure out what that minus 5 does. So you've got to ask yourself, is the minus 5 inside or outside the function? So if it's outside, it's going to affect the outputs. And maybe I have to travel back to that table at the beginning of our notes. If it's outside the function, the minus 5, we've got to figure out. So inputs aren't touched, the outputs move down 5. So we're looking at 0, negative 5, 1, negative 1, 4, 3. But we're going to keep this in mind, how the outputs move down 5. So as you graph it, we're going to keep that in mind. Outputs move down 5. So domain, x is greater than or equal to 0. Range is affected. You may want to put a star by this comment. I'm going to comment. You may want to put a star. If your inputs change, your domain changes. If your outputs change, then your range changes. For the next problems, we've actually already graphed them. All I want you to do is just write down their equation. We're going to talk about domain from the previous equation, y equals 3 times the cubed root of x. I realize you have a graph there, so I'm just going to show you the graph again. You don't have to copy the graph down. We're still just going to practice domain and range from what we graphed before. This graph also does not go up by 2's. This graph just stayed true to its unit. Ladies and gents, anytime we have an odd index, it will be, domain can be all real numbers, and range can be all real numbers. When it's even, that's when we have restrictions. So, now to graph, we will still have transformations. We may translate the graph left or right, but for odd indices, it's always going to be all real numbers. That if the inputs change, then the domain changes. That's only for even roots. So that correlation I just spoke about is only for even roots, for square roots. All right, next, this was the next function that we graphed. And again, it doesn't matter that it shifted right to, because no matter what, with an odd index, it's all real numbers for domain and all real numbers for range. Also going to talk about that next one that we did. It does not matter that the outputs changed because we're looking at an odd index. So it's still going to be all real numbers for the domain, all real numbers for the range. So those of you who are doing homework simultaneously with the lesson, because that's just how some of you learn, you can just look at your cube roots and go from there.